Well, here we are. Okay, so we are in the final throes of day number 1. We've only got 2 primary slots left, including in which is the keynote closing this out. So I don't know about you, but 2020 has proven to be just as fast at this conference as it has the entire rest of the year. So here we are. All right. So a couple of things to check out before we go is number 1, again, there's a keynote just following this here in just a little bit. So please make sure to tune in for that. And then also, if you have not been paying attention or have noticed some of the chats going on or announcements that are happening inside the open chat, make sure to check those out because there's a few different things that are coming up that may be very valuable to you in some area of your life. So don't forget that stuff. All right, without further ado, I want to introduce Soutaro. He is going to be giving us the state of Ruby 3 typing. So here we go. The stage is yours.
Okay, hello. Good afternoon. So my name is Soutaro. I'm an engineer working for Square in Tokyo. So yes, I'm speaking from Japan, and it is 6 a.m. now. So yeah, it's early morning. It's fine. So I developed a type checker for Ruby called Steep. I'm also a member of the Ruby committers team and working for types in the team too. So today, I will be talking about the state of Ruby 3 typing, what will happening in Ruby 3 about typing. So this is a really short summary of the Ruby 3 and typing. So Ruby 3 will ship with a feature to support type checkers. It includes a type definition language called RBS and a library called RBS Gem. It also includes type definitions in RBS of the standard libraries, including built-ins like string or arrays, set, path-name, like that. There will be several type checkers available for Ruby. But that we don't have a standard type checker for Ruby 3 is this one. So you can choose the best type checkers for your project and you install that and you will have the type checking experience with the type checkers you choose. So this is a small list of the type checkers available for Ruby. I want to introduce my type checker first. It's called Steep, and it is a static type checker for Ruby. And it's implemented in Ruby, so if you want to change something, you can write Ruby to change the behavior of Steep. Another one I should introduce is Solver. It is the first production-ready static type checker for Ruby. And it is the most widely used type checker for Ruby today. These type checkers, the Steep and Solver, assume that user writes some type declarations of the classes or modules, methods, instance variables, constants, globals, anything of the Ruby programs. But the type prof is different. It is an type checker developed by Mame for another Ruby committer, and it tries to infer the types of Ruby programs without any type declaration or type annotations. So it reads the original, the dynamically typed the Ruby programs, and it finds the relationship between the classes and how the methods are called with the arguments. And then it tries to generate the type definitions of the Ruby programs. It will be bundled with Ruby 3. It means that you can start using type prof just after you install Ruby 3. Another type checker I should mention is RBL. It is a research project, and the development team is led by the Professor Jeff Foster. They published some research papers about type checking for Ruby using the tool. So yeah, it means that we have at least 4 type checkers for Ruby today. So I want to start to explain what is the idea of static type checking. This is an example Ruby program. It makes a conference class object with the RubyConf2020 argument, and it should push some of the talks to the talks attribute of the conference instance, and it calls the each speaker method. So this is a really small Ruby program. It looks very obvious, but that we will have some questions about the program. The first one is what is the type of the new method? We pass a string argument to the new method, but we don't know what is the method signature of the new method. It may accept a symbol, or it may accept an integer for years, or maybe it's accept a keyword argument. How about talks? It looks like an array or something like collection, but it may be unset or hash. So we assume that talks object is an array, then we can use push method. But if it's unset or hash, we cannot use push method. We need to use a merge or maybe store or like that. We also have some assumption of the each speaker method. The method name starts with each. Then we guess that the method accepts block. But it's not clear how is the real signature of each speaker method. Or we need to know what the speaker, what kind of value will be yielded to the block. So what is the type of the speaker local variable? So this is the questions of the reading the source code. If we execute the Ruby program, it's easy to find the answers. If there is an incompatible method argument signatures, it will raise an argument error. Or if there is no push method, it will be no method error. But what we want to do with static type checking is that to know this information about this reasoning of the program without running the program. So, and for the static type checking, we introduce a feature of RBS. So what is RBS? It is a new language to define types of Ruby programs. It is to describe the API of a Ruby program, like the classes, modules, which methods are defined for each classes, how about the instance variables, the relationship between the classes, like the inheritance or not, or like the mixed ends, constants, globals. Using RBS, we can define the structure of the Ruby program. It also means RBS is a library and assets to help the type checker development. But today I focus on the RBS language. This is a very short example of the RBS class definition. So it is to define the conference class. There is no superclass specified in the declaration. It means its superclass is object. It has two ATTR reader syntax, name and talks. We can find the type of name is string, and the type of talks is array. how is the type of definition, how is the type of initialize method? It accepts a string argument. It's not keyword or it's not symbol, it's a string. Each speaker method has two overloads. The first one accepts a block, and the block will receive a speaker class instance. Or if we omit the block, it will return an enumerator object. So this is the API of the conference class. So using the class definition, the static type checker can reason about the Ruby programs more precisely. How is the method of the new, how is the argument of the new method? It will be find the answer from the type of the initialize method. So it accepts a string argument, so the calling a new method with a string argument is okay. How is the talks method of the conference object? It's an array, so there is a push method. This is okay. Each speaker will be, if we pass a block to the each speaker method, it will be a speaker object will be yielded. So the type of the speaker variable will be speaker instance. So we need to look up the definition of a speaker class, but there will be some name and email attributes. So using the RBS, we can find some of the informations of the Ruby programs. And we will find some problems like the passing some incompatible object to some method, or calling some undefined method, or we can do that kind of the checks called the type checking. Oops. I want to introduce some of the features of RBS. It has generics. The square bracket means it is a generic instance. So we can write something like the array of integer. It means it is an instance of array, and the element of the array is integer. We can write the hash of string and array of integer. It means the key of the hash is string, and the values of the hash object is array of integers. Union types allows defining a type like a string or symbol. It gives flexibility of the Ruby programs, so we don't need to define a common superclass, but we can write, oh, this is string or symbol. String or symbol is okay to be the value of the variable, the value of the expression, but it's not an integer or array or like that. Writing the union types in generics is okay. So array of string or integer means the element of array is string or it may be integer. We have an optional types. It is a shorthand of the union type with new. So integer question is equivalent to integer or new. It can be an integer instance or it can be new. This is important to reason about the nearability of an expression. It is a really common cause of no method error or some kind of the type errors. Interface types is to support the duck typing. This is an example of an integer convertible interface. It has a toInt method and it returns an integer instance, but there is no assumption that the superclass of a class or if it types requires to be mixed in it includes some modules also. So this is important to support the duck typing because that the interface type doesn't assume any inheritance relationship or mixing relationship. So we can just pass an object if it has a toInt method. You might find that interface types start with an underscore. So this is intentional. Interface types doesn't appear in the Ruby programs. There is no class or module for associated to the interface type. So it means that there can be some name collisions in the RBS world and the Ruby world. So to avoid that conflict, we need to put an underscore before the name of interface. The last one is an untyped type. This is a special type that the static type checker skips any type checking on the untyped type. This is typically useful for the return value of the eval method. It evaluates a string, and the return value depends on the contents of string. So it's difficult to reason about the return value of an eval. So untyped is used here to make that type checker give up doing something for that value. Oh, it is an equivalent on any type of TypeScript. So this is a Git repository of the RBS library. It contains the RBS files for standard libraries and RBS for the RBS library itself. The library is not very big library, but it's a real Ruby program, so you may find some examples of the real world RBS files. So this is about the language of the RBS. I want to explain some of the how RBS files can be grouped, and then so we want to define the three types of the RBS files: the standard library types, gem types, and application types. So standard library types are the type of the standard libraries, or I mean the core library, string or array. So Ruby committers write the files, and all of the Ruby developers will use that RBS files. Gem types is the RBS file of gems. The gem authors will release their gems, including the RBS files, or the community. You can write the RBS files of the gems if the gem author didn't zip the RBS files. The last one is the application types. So this is the developer of the app write the type signatures of the applications, and the developer of the application uses the type definitions. So I want to say that the main target of RBS are standard library types and gem types. So I want to show a diagram of how the RBS can be used. So there will be several type checkers, A, B, or C, like that. So we hope that the type checkers will support the RBS syntax, RBS language for the gem types and standard library types. But that we are not talking about the application type definitions. They would have some different native type declaration languages, and they may continue using the type definition languages of each type checker. Maybe type checker, the blue one, will try to will continue using the native type definition type declaration languages for some of the libraries, or maybe the type checker sheet, the part 1, we will try to use RBS for application types. So there can be some levels of the adaptations to the RBS of each type checker. So this is the actual type checkers are doing for RBS. Steve uses an RBS for the primary type definition language. It reads the types for libraries from RBS files, and it uses the RBS for application types too. So the Steve users will write the RBS for the type of the application, and yeah, like that. Typeprof also supports RBS. It allows the RBS files for the library types, and it infers the types of your Ruby programs without type annotation. So it means that the application types are not assumed by the typeprof. How about Sorbet? It uses an Sorbet RBI as its native type declaration language. The Sorbet will continue to support the RBI files, and yeah, we hope that they say that they will support some of the subset of the RBS files too. Okay, so this is a very quick introduction of RBS, and yeah, when we explain the idea of RBS, we receive this question frequently that why it requires writing types in another file. So embedding type declaration in Ruby code would be better because that having different files requires editing two files to change a method, the name of method or like that. Yeah, I know that. So yeah, there are several reasons. The first one is that to avoid writing types in Ruby code. So this is a request from Matz because that he believes that type annotation will be outdated in future. He says that in some keynotes several times. And yeah, then he wants no types written in Ruby code. I'm not very sure if it could happen, but that, yeah, I think that is not too bad because that it will help to keep the feeling of that type checking in Ruby is optional. We know that not all of the Ruby developers are interested in type checking, so we don't want to discourage the using Ruby as an untyped or dynamically typed language. So yeah, it's optional in Ruby. The last one is somewhat technical that we need to support the libraries written in C or anything other than Ruby. So there is no Ruby code, then we need some way to support to declare the types in that extensions libraries. So I want to note that the inline type annotations, it's just out of scope of RBS. We know that type checkers, including Sorbet and Steve, need inline type annotations. So RBS is not to duplicate the inline type annotations. The inline type annotations are needed for the type checkers, and how to use the inline type annotation is totally up to each type checker. Okay, so I want to talk about the RBS of Ruby Gems. So the Ruby committer team write the standard library RBS files, but the Ruby applications today depends on a lot of libraries, a lot of third-party libraries. Type checker needs the type of libraries to work well with libraries, and libraries are Ruby gems. So it means that we need the RBS of gems. So I want to explain the two steps, how we can distribute the RBS of Ruby gems, and I want to explain about how we can write RBS files. So the first option is that releasing gems with RBS. This is super simple. Just make an SIG directory and put RBS files there. This is an example of a gem called strong.json. This is my gem. And it has a SIG directory at the root of the repository. And there are 3 RBS files in the directory. And you will find that the RBS files will be included in the .gem file. So when RBS gem is trying to load a library, it will scan the SIG directory and load the RBS files in that directory. Another one is that to add an RBS files for existing gems. Even if the author of a gem don't want to release gems with RBS files, we need RBS files for the gem. So I have a Git repository called gem RBS for the place to collect the RBS file for the Ruby gems. So the screenshot is an example of the Redis gem 4.2. So we have the gems / the name of gem and the version directory, and put some of the RBS files and some supporting files. So I want to note that multiple versions of an Ruby gem is supported. So if we want to have an Redis gem, the RBS file for Redis gem for version 3, then we can make a gems Redis 3.0 directory and put the RBS files for that version in that directory. Another one is that the version name resolution of RBS is a bit different from some of the popular system called semantic versioning. It is optimistic. It means that if the version 3.2.1 is required, then it will resolve to 4.2 if there is no better version available. So if it is semantic versioning, the 3.2.1 and 4.2 is incompatible because the major version is different. So the semantic versioning system will fail to resolve to the 3.2.1 to 4.2, but the RBS does. So it is because that we believe that having some incompatible type signature is better than don't have any type signature. And yeah, it is about the type checking. So if you find that incompatibility is a problem, then you can just disable to loading the gems, loading the RBS file, and you can fall back to manually return polyfills. And okay, oh no, the time is difficult. Okay, so yeah, I want to note about the writing RBS of gems. So you can manually write the RBS files reading the source code, but we provide some tools. And yeah, there is an option to generating RBS files from YARD documentation. I want to show the demonstration of the type prof. It is another static type checker. So it will scan the Ruby source code and do some smart analysis, and it will print some of the it will print the RBS files with some of the specific types. So we can see there is an import loader class, and the attributes cache path is a path name, or the type of the initialize is a keyword arguments, and we can see the type of each keyword. So yeah, there is another tool that RBS plot type but that type prof is much better for this kind of the analysis. But that we need to mention that there is some untyped type left in the RBS. So we need to take care of we need to review the RBS file generated by typeprof, and we need to edit the file for better types. Okay, so this is a summary of my talk. The Ruby 3 will ship with a feature to support type checkers. And the several type checkers are available for Ruby, and you can choose the best type checker for your projects. And we made a GitHub repository that Ruby/gem RBS, and it will be a collection of the third-party RBS files of Ruby gems. So yeah, thank you for watching my presentation. The RBS has a lot of the issues or problems, so let me know if you have any feedbacks or questions or like that. So thank you so much again. Oh, is it okay?